Okay. So we are covering this textbook 1, and chapter is about hull forms, and lines are also together inside the hull forms. This chapter. And hull form is covered by subtopics of hull form definition and lines drawing and hydrostatic curves. Right. This is a picture coming from a museum. And you see that there's a turtle ship. Korea, old, how many years? 500 years ago. And then you see that there is turtle ship. Now here is turtle, right? Looks like a turtle. And probably this is something like directors, captains, or general's ship. So there is commander. Commander is there, probably. And then there was a war between Japan and Korea in these years. Okay. And then I will try to explain about the whole form of this turtle ship. Right. So there is a video. Okay. If, yeah. Have you heard about turtle ship before from French? Yes?
The Royal Korean Navy during the Joseon dynasty at the beginning of the 15th century created the first sketches of what would later become one of the most powerful and deadly warships of the time, the Turtle Ship. The Turtle Ship, also known as Kabukson, was used from the beginning of the 15th century until the 19th century, being of great importance during the Japanese attempts of invasion of Korea at the end of the 16th century. Let's see now the 7 curiosities of this deadly weapon of war. Number 1. The Turtle Ship was the first battleship in the history of mankind. However, we must not ignore the existence of historians who do not agree that these ships had an iron roof, thus not being considered as battleships. Moreover, some other historians believe that armored boats existed before the turtle ship, such as the Santa Ana Carrack of the Order of Malta in 1522. 2. These ships played a decisive role in the Japanese attempts of invasion of Korea. Without this ship, the Japanese would have won probably. 3. Although it has a turtle shell design, the turtle ship has a dragon head in the prow. 4. The dragon head was not only decoration, it was also a weapon, and very interesting by the way. Toxic fumes came out of the dragon's mouth, usually sulfide gases. Therefore, the dragon's head was a chemical weapon. Sometimes the dragon head was also used as a flamethrower. 5. The ship had a dozen cannons on each side. However, in the first years of the turtle ships, the cannons did not throw cannonballs, but arrows. These arrows were made of wood and iron type, whose mission was to create large holes in the enemy ships. Furthermore, these arrows were thrown at 320 kilometers per hour, so they were quite effective. 6. On the upper deck, there were sharp iron spikes in order to avoid boarding. These spikes were incorporated because the Japanese Navy preferred boarding in naval battles, so the existence of these large spikes frustrated the Japanese tactics. 7. There are replicas of the turtle ship in South Korea that can be visited. For example, the replica of the image is placed in Yosu. This is all for today. We wait for you in the next video. 18 curiosities about Otto von Bismarck.
Right. There is another picture. But this one is coming from Japan side. The picture. I mean, you may not see the difference. There is all Chinese characters. So, but anyway, this one is picture is coming from Japan. So this is ships coming from Japan, and comparing to the previous one, there are difference between what most big difference is turtle ship, the shape, and also in terms of hull form, and also the difference is gun and also a pistol something, right? Rifle. So that the Japan ship need to travel to the Korea, and between Korea and Japan, the distance is not so far, but the sea is very rough between. Short distance with a rough water, so that they need to have a very how can I say, thin and narrow ship type to go through the rough sea. Right? But turtle ship is very wide and bull shape. So the length breadth ratio is much different. Right? The turtle ship is length is short and breadth is wide. So it is designed for defensive system rather than offensive system. Japan ship need to travel to the Korea to go through the rough sea, so that their ship is very thin and narrow, sharp, and narrow in breadth, and speed is high. Turtle ship is very slow. But advantage of turtle ship is, even though it is slow, they have enough space for placing guns. Guns have a more longer distance for shooting. Compared to Japan side is having more, because this ship is narrow and small, there is no big guns inside. They use only rifles and knife. So that's why they need to come to the ship, on board the ship to fight, to win. But Korean, the turtle ship want to be far, more distance from the Japan ship, and then shooting by guns fire. So different performance make it different to tactics. So then how to make them battle to win? So Japan need to come to closer. Koreans go some distance to make a shooting of guns and also and fire arrows. So that's why I'm showing this drag coefficient coming from hydrodynamics books. So this one is a streamlined head body, has a drag coefficient is very small, right? Comparing to blunt body like this. How many times of difference? or 10 times or 5 times higher. Or which one is the biggest? This one is the biggest. 20 times higher real coefficient. So in the turtle shape looks like this kind of shape. And Japan shape may be a little bit something like this shape. That's why this one is good for hydrodynamics and resistance of fluid. So their speed is higher. And then also seaworthiness, we call this seaworthiness. Right, oh, this here is the more nice picture. So this one is a Korean ship, a baseline of the turtle ship. The turtle ship is use this baseline ship and then make a cover over the top. We call this is a cannon gun, and that has a long range of firing. But this one is from Japan ship. And they basically use a rifle and then short range batteries, better foot, and also knife. And they have a more skill on this kind of short distance battle. So once again, the hull form proportion ratio is different because the drag coefficient of this kind of ship is higher in comparing to this. We'll see more on this stage. So the same one in different form, the drag coefficient. And flat plate is higher, flat, blunt one. But airfoil is lowest. And bullet is prism and steel. So you have an equation for this drag coefficient in hydrodynamics or fluid dynamics. This one is just model size. We working on battle between Korea and Japan this time. Right. So the hull form again. The turtle ship of Korea and Sekibune of Japan. The hull form is wide and short ship, but this one is narrow and long ship in proportion wise. So advantage is this is stable and the deck area is wide enough so that they can place big guns. This one is lower resistance for high speed, so it's easy to propelling a ship to get high speed. And the cost of construction, because this is a blunt one, it is easier to build or less cost. But this one is because the shape is drag coefficient is small, it need a small power to propelling. The speed is slow and high, and motion in waves. The rough sea between Korea and Japan, this ship is better in rough sea, so that they can be used for coming to Korea easily. So this one is not good for in wavy rough seas. Okay, right. Then how we designing a ship using owner's requirement, and there are different requirements coming. Something like if you think about how to build your home, then the building type should be concrete building home or wooden home or steel home. So there is a type of ship like a container ship or battleship, yacht, something. And dead weight, how much cargo can be loaded, and capacity in terms. This one is in terms of weight, tons. In terms of this is volume or area. And one of the main requirements is speed. So speed is related with the hull form. And this one shows COT efficiency in different cargo carriers. There is a crude oil tanker, LNG tanker, general cargo ship. Reefer is a refrigerator ship. Refrigerator ship. And then chemical tanker, bulk carrier, container ship, LPG. LPG is similar to LNG, but the temperature is different. And pressure is also different. And product carrier, chemical product carrier. And RoRo is a rolling on, rolling off, roll on, roll off vehicle. Something like a ferry. Ferry is carrying automobiles and trucks. We call this RoRo ship. Roll on, roll off ship. And rail carrier. Oh, this one is just a train rail. And then road trucks. And then this one gives you ton-kilometer per gram of CO2 production. So that big ships can be very low emission. Comparing to this, but you need to see this phenomenon. Right? And this one is an ideal ship coming from Japan. Is a shipping company from Japan, and they call this is a super eco ship 2030. And then comparison between CO2 or other things, comparing to conventional 8,000 TEU container. So length is similar. Breadth is, this one is bigger, and the depth is a little bit similar. But main power is a diesel engine, conventional, and 60 megawatts. But this one has LNG fuel cell, LNG-based fuel cell, so that they generate electricity. Fuel cell generating electricity. And total power is 40 megawatt because they have a sailing on the top of the ship. And renewable energy is used by solar panels and also wind panels, or not panels, sails. So CO2 emission is big difference between these two ships. Now the green item goes also to the ocean area, including ships and ocean planes. So now we go on to 12 form definitions. Linear measurement, something like length and breadth. And then 2- and 3-dimensional characteristics, coefficient and speed and Hall proportion. So the linear measurement, about length first. There are 3 different length scales in ship. Length overall is starting from end to end, right? Very end of the ship, very front of the ship. So the length overall is total length. And then length waterline is only this one. This is a waterline. Whether the ship is floating up to this water level, so this one is waterline, or probably a draft line. And the length is between or along the waterline. LWL, length of waterline, is from here to somewhere here, right? And then length between perpendicular is special. Although this one is used for shipbuilding company, and designing is also based on this. So there is a 2 perpendiculars. One is after perpendicular, and there is another 4 perpendicular. Depending on the designing and construction methodology, usually the AP goes with together with the rudder shaft. There is a rudder. This one is the rudder of the ship. So rudder shaft will usually be the line of a peak tank. And front one usually goes with similar to the waterline structure. Anyway, then by dividing this LBP between perpendicular, you prove probably use stations of 10 division or 20 division, and design is starting along these stations. We call it station. You see in later stage. And then this one is because based on design and construction, the classification society and insurance company and tax is based on this length rather than others. This one, the waterline length is used mainly for hydrodynamic calculations, something like a resistance calculation or ship motion over the water, wave, rough sea. We need to calculate, predict the motion of the ship. Then we use this level because of the water line. And length overall is not used well, but sometimes it is useful for checking whether the ship can pass through the canal or small region or canal or between gate, because this is the overall length of the ship. So inside the canal length should be, there is a limitation. Transverse hull form characteristics, there is a breadth and depth. Depth is usually up to the upper deck. There is deck, main deck or upper deck. This is the main deck. Depth is up to this main deck. And draft is, there is a two different draft, but usually very similar area, but the baseline is a little bit different. So design draft is something like this one, but also there is a scantling draft. This is based on structural design. This one is for the weight calculation or volume calculation, or dead weight and speed power performance is based on this design draft. And this one is mainly focused on structural strength calculation. But usually they have a very small difference between two drafts. And this one is to show you what is the meaning of payload. This small cargo truck is famous inside Korea. The maker is Hyundai Motors. Brand name is Porter. And you see this one. This one is saying 1,000 kilograms. So maximum cargo this truck can transport is 1 ton. And what is this? This is PS, means probably the engine power. So same concept, like cargo capacity is goes to the payload of the ship. And midsection drawing is one of the key drawing. I asked you about what is the three main drawings of the ship design. Right? One of them is a midsection drawing, and this one is a midsection drawing, part of midsection. And this is three-dimensional real story picture of it. And there is a different wordings of that. And freeboard is here. And camber, design draft, model outline, depth is here. Right. But you see that there are many frames. We call this frames, different type of frames. And this one is we call it the transverse frames. Transverse frame. Transverse means the ship looks like this one. There is a frame like this. We call it transverse frame. There is also longitudinal frame too. You see something like this one. This one is a longitudinal frame. Also, this is a longitudinal frame. And you may not have a chance to see the even ship, but also the airplane structure, very similar to this. And also you may think about the human body, also fish body. Fish body also have frames. So that mimicking this coming from the natural phenomena. Right? So this one is a wooden ship